Well, this is a bittersweet moment for sure. It is the final day of our journey with Crew, fifth day of week 3 while we complete the work we've got with Crew, and it's going to be a great one. We're going to end on a high. We are going to build on the project we did last time. On day 4, we are going to turn our coder into an engineering team. We're going to have an engineering lead, depicted here by this person chilling out, because that's what leads do. We're going to have a back-end engineer. We're going to have a front-end engineer, and we're going to have a test engineer. Seen here as someone that's jumping on top, trying to destroy, trying to break everything that they are given. So this is going to be our team. We're going to really use the Crew in Crew AI. Let's get to it. And welcome back to Cursor. Welcome to our final project for Crew. Let's bring up a terminal with Control and the back tick. Let's go into that third directory. And now, of course, it is a time to do Crew AI create, Crew, and it is engineering_team is the name of our project. Let's do it. Let's choose the options that it tells us. We want OpenAI, we want GPT-4o mini, and then we skip making a token. And then there we have our directory structure. And now, of course, we go into engineering team, we go into source, we go into config, and we open our agents.yaml file. As usual, we see the boilerplate ones there, the researcher and the reporting analyst. So what are we going to do? Well, we're going to, first of all, delete what we have here, and we're going to put in our first agent. And our first agent is going to be an engineering lead. The engineering lead for the engineering team, directing the work of the engineers. Let's make that plural. Take the high level requirements described here and prepare a detailed design for the backend developer. Maybe we'll leave this singular for now if it's just one developer. Everything should be in one Python module. Describe the function, the methods, signatures in the module. The Python module must be completely self-contained and ready so that it can be tested or have a simple UI built. Here are the requirements. So this is going to be one of our input attributes that we can pass in. The module should be named module name, and the class should be named class name. So we are going to bring in those as well. So we're going to have this be a little bit configurable. And the backstory, you're a seasoned engineering lead with a knack for writing clear and concise designs. Okay, there we go. So look, I'm going to put on an LLM now, and let's have something different to usual. I think we're going to go with GPT-4o. We're going to have the big guy. I've also run this with GPT-4o mini, and it runs just fine. So you can do that too if you wish, and you get you get a bit more comprehensive, extensive solutions if you use its bigger cousin GPT-4o. Okay. So, and whilst that will work, of course, the full way to do it is to show this as OpenAI / like that with the provider. That is the first of our agents. Okay, so the next agent is going to be called a backend engineer. So the backend engineer is going to be a Python engineer who can write code to achieve the design described by the engineering lead. So the engineering lead will do the design, will lay out the sort of foundations, and the backend engineer will do the coding. Write Python module that implements the design described by the engineering lead, but we'll also pass in the requirements again. So it's going to get the requirements along with the design and the module name and class name again. And it's given a decent backstory saying that it's a Python engineer with a knack for writing clean, efficient code. Follow the design instructions carefully. So again, we'll use a different model. We'll mix things up. And this time I suggest we use Claude 3.7 Sonnet latest. Now, sometimes we get an overload error from Claude, at least I do as of now. So it's a little bit less stable, but nonetheless, it's a great coding model particularly. So I think it's a good one to use in this case. All right, let's also add a front-end engineer. And I say front-end engineer, but it's going to be a Gradio engineer, a Gradio expert who can write a simple front-end to demonstrate a back-end. Write a Gradio UI that demonstrates the given back-end all in one file to be in the same directory as the back-end module. Giving the requirements, giving the backstory, a seasoned engineer, highly skilled at writing simple Gradio UIs for a back-end class. But there we have it. We explain that the Gradio UI needs to be in one module, and we'll use again Claude for this too. Okay, and one more agent, our final agent, is going to be a test engineer. But I'm slightly abusing the word there. It's not like a QA engineer. This is going to be a Python coder who knows how to write unit tests for a given backend module, because I want to see unit tests being built out here. So that's what the test engineer is going to do. They're going to create a test, which is going to be called test underscore and the name of the module, which will be the backend module. And they're a seasoned QA engineer and software developer who writes great unit tests for Python code is the backstory. And, for all of the coding part, we'll use Anthropic. Oh, maybe we should shake it up. Why don't we take a risk? We'll use DeepSeek instead. DeepSeek. I'm just going to stick with DeepSeek Chat because DeepSeek Chat is also able to write terrific code as well. So we'll stick with that model. And that will be our test engineer. Now it's time for us to go on to the tasks. So look, it's a bit repetitive. Let me get rid of the gunk. We're going to have a task for each agent. And it's funny, this is one of those times when it feels like OpenAI's Agents SDK is sort of more straightforward, that they don't have this extra indirection, this idea of a task being a separate first-class object. Because there's a lot of times that you will have this one-to-one mapping between a task and an agent. Obviously, Crew has built this up because they really want you to think in terms of situations where you will have series of tasks that will be given to the same agent. And we did see that in at least one of our examples. But in this case, we are again going to have the case that there's going to be a task for each of our agents. And it gives us an opportunity to spell out very clearly what's required. So the description of the task is to take the high-level requirements described and prepare a detailed design for the engineer. This is the design task that, of course, is going to be assigned to our engineering lead. And the output is a detailed design for the engineer. You'll notice that I make it important that it should only output the design in Markdown format. Otherwise, it just wants to start writing the code, which is not exactly what we want. And here we specify the output as the module name underscore design. And it's worth noting that you can have these templated tags in the output file name as well. You can have it anywhere in this YAML and it will get substituted in for the actual name of the module that we're building here. So that is the design task. My next one, Cursor wants it to be called coding task, but when I wrote it, I wrote code task. There we go. I like to be unpredictable. So the description is write a Python module that implements the design as described by the engineering lead in order to achieve the requirements. And then here I'm saying important, output only the Python code without any markdown formatting or code block delimiters or backticks. And that's important because these models love to output markdown. And if you don't put that note in there, it's going to put that tick, tick, tick Python at the top of the file, which means it won't be a valid Python file. And it just loves doing that. So unless you really highlight this is important, it's going to do it. And so that is the task. And we're saying context, design task, which you remember is going to make sure that that information is made available to it. And generally speaking, you can think of the tasks as being the user prompts and the agents as defining the system prompts. And that's kind of how it all comes together. And this context is showing us what kind of information is going to be included in that prompt from others. Okay, so that is the code task. How about the front end task? So this is where the plot thickens. The front end has got to write a Gradio UI in a module app.py that demonstrates the given backend class. Assume there's only one user and keep the UI very simple indeed. Just a prototype or demo. Here are the requirements. And so, yeah, we keep it nice and simple. Maybe I'm going to take out the very simple indeed. Let's just say keep the UI simple and keep the UI clean. Let's leave it at that. So important, only output the raw Python code again. The agent is the front-end engineer agent, obviously. And of course, for its context, it needs to get the output from the code task because it's going to write a user interface, which is going to directly use what the code task has written. So that's going to be very interesting to see how it's able to keep that context so well that it's actually able to do this. And then Cursor is correct that the last one is indeed called test task. but it's got a little bit more detail than Cursor was suggesting. Write unit tests for the given backend module and create a test in the same directory. And this is got more information one more time about outputting raw Python without clever tags. And of course, it also depends on the code task. The unit tests are not going to test the user interface. It's going to test the code, and that will be the output file. And that is it for our tasks, a one-to-one, again, between the task and the agent. Okay, it's time for us to go to the crew module. As well, you know that that's the next step. And of course, you also know that I like to get rid of all of the gunk. No more gunk for us, but we'll keep in, of course, the hooking up to the YAML files. Let's get rid of everything else from here, and we will do our work to define the agents. So agents, the first agent is called the engineering lead, and good old Cursor is giving us some good suggestions here, but not perfect because we don't need the engineering lead to be able to execute code. That's not its idea. It's just meant to be designing stuff. All right, but now the backend engineer. So thank you, Cursor, for that, but you have missed this time what we really need here. So we do indeed want it to be able to have code execution. We want the code execution to be safe in a Docker container. Absolutely. The max execution time, we probably want to give it a bit, well, not that long. That's rather too long. Let's give it a few minutes to work on this. Why not? And then max retries, we'll give it 5 times before we are upset. That seems pretty good. Okay, the front-end engineer. Oops, need to remember my decorator. The front-end engineer, let's have a look. So actually, we're going to have it right front-end, but we're not going to have it try and execute, because that would bring up a Gradio UI in the Docker container. That'd be a whole different ball game. So we're not going to do that, but we are going to have it do its creation. And now we just have the test engineer. So thank you, Cursor. And that seems like a good enough start, but the test engineer, we absolutely want the test engineer to not only write the unit tests, but then to run the unit tests. But it probably doesn't need, we'll give it a couple of minutes to do that, and we'll give it 5 retries as well. That seems fine. Okay, those are our agents. Next, it's time for us to define our tasks. And this is going to start to get very complicated. The design task is just going to look like that. And I bet Cursor's going to know everything else. That's all we want for the code task now. And let's see if it can help us more. That's probably great for the front end task. And the test task, is it going to help us with that? Yes, it is. It's got it strangely indented, but no, it's brought it back. That's nice. And I think that's it for our tasks. I don't think there's anything missing here. Perfect. All right. Thank you, Cursor. Those are indeed our tasks. It's time, though. It's time for our crew. Let's see if Cursor could do this. Oh, no. That's all a disaster. This is a moment to definitely mention that you do have to be mindful of this, the whole vibe coding thing. As I said before, it is common for LLMs to generate too much code and to just put stuff in there. And often people send me problems they've got, and I can see that they've used an LLM to generate lots of code because it will tend to err on the side of more. Of course, in this situation, we don't need to list out all of the agents like this. We can just say the agents are self.agents. That's the why we decorated them. And we can say that the tasks is self.tasks, and we also need to mention that the process is process.sequential, and verbose is true, and that really is it. But we would normally call this dev crew like that. And I think we've got it. Okay. Well, you know what's left. We have to do our run function. We will come to that right now. Okay. This is the usual main full of stuff. Going to delete all of that. Going to delete all of this stuff here and leave us with something very simple. So let's have a think about this run. So first of all, we know that the what we've got here is we've got requirements are going to be, let's just give ourselves a variable that we'll have a variable requirements. Okay. Module name was one of them, and we'll have that be a variable module name, and class name is going to be a variable class name. Isn't it great the way, again, cursor just guesses, since we had that before, that that's going to be our thing. And now engineering team.crew, that's because that the function, the method that we decorated with the crew is indeed called crew.kickoff with our inputs. Okay, so all that remains now is for us to actually come up with the assignment. And I have produced an assignment, which I wish to show you now, and which I think you may find rather interesting. So here is the coding challenge that we have for our team of agents. Let me tell you about this challenge, and then I'm going to tell you why this is an interesting challenge. So the requirements. We would like a simple account management system for a trading simulation platform. The system should allow users to create an account, deposit funds, and withdraw funds. The system should allow users to record that they've bought or sold shares, and providing a quantity, it should be able to calculate the total value of the user's portfolio and the profit or loss from the initial deposit. The system should be able to report the holdings of a user at any time and the P&L at any time. And it should be able to list the transactions that the user has made. And it should prevent the user from withdrawing funds that would leave them with a negative balance, or buying shares that they can't afford, or selling shares that they don't possess. And I'm telling it, the system has access to a function getSharePrice, which returns the current price of a share and includes an implementation that returns a fixed price for 3 shares there. So that should be built into this code. So that's the challenge. It's like to build a kind of framework for simulating trading activity, which, that's a fair bit of work to do that properly. That's not going to be easy. And you may wonder why this particular challenge? Well, here's the thing. In the last week of our course, we are going to try to build agent traders. We're going to be using, back to OpenAI Agents SDK, and we're going to be using MCP. It's going to be really cool. And the idea is going to be, can we build like a set of traders, of agents that are able to monitor financial markets, look at actual live real-time prices, and make trading decisions? But for this to work, we're going to want to have a kind of framework that they can make trades in, and that framework that will keep track of portfolios and so on. And there are some frameworks that you can get off the shelf, but they're very heavyweight because they're this sort of big financial markets backtesting frameworks. There isn't something that I could find easily that's just a lightweight account management, stock portfolio management framework. And so I thought, why don't we get AI to build it for us? And what could be better than having our own crew, our own engineering team, take on this challenge and try and build out this whole framework for us. So that's why this is a 2-for-1. Not only are we doing this week's project, putting together a crew of software engineers and a test engineer and so on, but also this is going to hopefully provide us with a framework that we'll then be able to reuse, give us a head start in week 6, so we don't have to build our own and do a whole ton of coding. So it's actually going to save us some time as well to boot. Well, with that introduction, I think it's time to try and run this thing. Not so fast, you say. You notice that I'm missing the setting the module name and the class name, which we also have to do. There we go. Module name is accounts.py and the class name is account. And actually, that wasn't the only mistake. Also in tasks.yaml, I had some stray tabs going on, that some of these things weren't formatted properly. And I'll tell you the reason I found that out is because I tried to run this and it failed. The error message I got was quite obscure. It was like some long stack trace, and it was not immediately obvious what was wrong. And I think, I had to go through quite carefully and look for problems. And I sort of had a clue about the kind of thing I was looking for. But I can imagine if you're new to using Crew, then that could be quite a painful experience because there's not many clues given to where to go. And I really think that's the deal that you make. Signing up for a framework like this, you get a lot out of the box. You get a lot of a head start. Think of the memory stuff that we did last time and the whole way that this fits together, and the code execution stuff. I mean, it's amazing. But what you get that you are trading off is the fact that some stuff is hidden from you. And when things go wrong, it can be harder to debug and figure out what's actually happening behind the scenes. But anyway, with all of that, it should be time now for us to actually give this a try. So we go into our directory, we go into engineering team, and we get ready to run crew AI run. Okay, here we go. And it's off thinking. Okay, the engineering lead is starting off. The engineering lead, of course, that is GPT-4o. The way I have it set up, you may have picked a different model. You may even be trying it with Olama. Now, I will say that if you are trying it with Olama, if you're looking for the free service, I do imagine that this will stretch Olama to the max. This is going to be a very, very hard challenge. And depending on which model you pick underneath Olama, you may have limited success with this. This may be a case of where you have to watch what I'm doing here, and I'm saving the results in an example output folder so that you can have that to hand. And, this might give you something to watch and learn from rather than running it yourself. But if you want to try it with GPT-4o Mini, that should work just fine. Anyway, we can see that it's done the design. It's now in the hands of the Python engineer. And I know that this can now take a couple of minutes. In fact, I think last time it took about 5 minutes to run all the way through. And that wasn't with DeepSeek, and DeepSeek can be a bit slower. So we'll see what happens. I will be right back in a minute. Okay, it just finished. It's exciting. I guess it did take about 5 minutes, I think. Let's have a look at what was produced in the output folder. So I guess, well, there's a lot of files there. That's a good start. Let's start with the design document. It is indeed in Markdown. It's, let's get rid of this terminal. It's got certainly like a design written out there, and it's got like method signatures and things. That seems great. And now the big guy, accounts.py. Okay. So it's got the get share price dummy at the top, which is what we wanted to return a share price for Apple, Tesla, and Google as example to seed it. Okay, class account, that's good. And it's got the right kinds of setups, deposit accounts, withdraw accounts, with comments, with doc strings. Okay, that looks good from eyeballing. I'm seeing good looking stuff. Obviously, we'd expect to see price times quantity. And then I see they're going to return false or return true, depending on whether it's successful or not. That's interesting. Okay. And yeah, this all looks pretty comprehensive, doesn't it? Calculate profit or loss, get the holdings, takes a copy. That's a pro thing to have done. I wouldn't have even thought of that if I was doing it myself. That, of course, is the right thing to do. Okay. Very nice. This looks very comprehensive. This looks like the code we were looking for. Let's look at the test accounts. Sure. I mean, these are the kinds of tests you'd expect. Plenty of assertions in here. That's great. And then that's the right kind of scaffolding around a unit test. And there is an app.py, but we're not going to look at that app.py because we're going to look at it in a whole different way when I'm back. Let's try this. Okay, so I've gone into a terminal now as we try out the code written by our engineering team, by our front-end developer. We're going to go into the folder called output. Here we are. Now, I imagine that we're going to need to install Gradio. I imagine if we just do uv app.py, it's going to have an import failure. Let's try this, uv run app.py, which you remember uv run is the equivalent of Python when you're using UV environment. Let me see. No module named Gradio. Okay, so I have to do uv add Gradio, and it's now added. And now we try this again, uv run app.py. Okay, it's thinking. It's doing its stuff. Thinking, it hasn't crashed. It's loading the various Gradio dependencies right now, I believe. Okay, so it's started a Gradio app. This is kind of crazy. Follow the link. Okay, here we go. Here is a user interface. Okay, so first of all, the first thing I'll notice, you're getting like a raw reaction video here. I'm like astonished. You can see that it's done a Gradio app with these tabs, account management, trading, and reports. That's cool. So create an account. I get to give it a user ID. So I guess I'll call it Ed, initial deposit. We'll put that in. I'll press create account. Account created for Ed with initial deposit of 10,000. And there we go. Holdings, no holdings. All right, fine. Now we go over to, I guess I can withdraw and add. That's cool. I'll go to trading. We'll do symbol, Apple, quantity 1, buy shares. And here we go. Successfully bought 1 share of Apple at, let's zoom out a bit. Let's see if we can, there we go. Zoom out again at that much. So the user is Ed. That's now my cash balance that's come down. The portfolio value is, of course, the full amount because I've spent some money, but I've bought equivalent Apple shares. So it's calculating that right. And there's the holdings, one share at 150 each. That's great. Let's go over to reports. Portfolio value is 10,000. Profit loss, 0. Current holdings is there. Transaction history, deposit and buy shares. This is great. This is so cool. I can't believe this. This isn't a simple user interface. This is a really good user interface. Look at the way things are organized into groups and are nicely laid out. I'm kind of surprised about this because actually in the past I've used GPT-4o Mini and it's not looked as good as this. It's worked for sure. But this is a sharp user interface with tabs, with sections, organized quite nicely. And I guess we better, let's try selling a share of Tesla that we don't have. Quantity 1, sell shares. Error, insufficient shares to sell. Okay, we get an error message. Now let's try selling an Apple share, sell share. Successfully sold 1 share of Apple. And now we have no holdings. And if we go and look at our transactions, hopefully we'll see that we both bought and sold. Transaction history, buy 1 share of Apple, sell 1 share of Apple. Well, I got to tell you, this is astonishing. This isn't a fake. I haven't run this in advance to see this before. You're getting my raw reaction, and it's definitely surpassing my expectations in terms of this being a nice user interface. Like if I had built this, I would be quite pleased with it. Frankly, I'm astonished. So that's a great conclusion. I will be sure to make sure I'll put some examples in example outputs. I'll try and put one with Mini so you can see a more raw user interface and then something like this. And yeah, it's really amazing to see. So a collaboration between GPT-4o and Claude 3.7 and DeepSeek to build this platform with, frankly, a really impressive user interface. Wow. So I am genuinely blown away by how well that did and you know, again, how easy it was for us to get to that point of having this crew of different agents building that product. And the fact that user interface just worked right away. Like it just came up and it ran and it looked so great. And the functionality behind it, there was like a front end and a back end and it all held together and did its thing. So I hope that you're going through the same as what I'm going through, some disbelief, and I hope you're seeing similar results. I've put that particular example in something called example output new, and there's also, you'll see a couple of other examples in there if you want to try out the ones that I generated, but you should try it yourself, play with different models, and experiment. And that's not all you should experiment with. Now, this week has some important projects for you. This is where you really learn. You learn by building stuff yourself, by coming in, take an example like this and just build it step by step. Take it a piece at a time, gradually add to it. So the first way you can add to it, the easy way you can add to it, is to have your team grow. Your team is hiring, add in some more. The role that I called test engineer wasn't really a test engineer because this was something that wrote test cases, but you could actually have a test engineer that's responsible for going through, maybe writing a test plan and then executing the test plan. You could add a business analyst that fleshes out the requirements. You could have some more detail. You could have an even richer user interface. Honestly, the sky's the limit with this. We're just scratching the surface. We only had 4 people in this team and you can just keep on and on going and try different models and see where it takes you. But that's the relatively easy change. There is then a harder change for you, which is the real challenge of the week. And here it is. So the thing is that this was all very well, but ultimately it only produced one Python module for the backend code. And then, of course, front-end module to go with it and a test module to go with that. But it was all still very much on Rails in that there was just the one module that was already fixed at the beginning. Now, it will be a lot better if your team could build a whole system piece by piece, working on the different classes to build the different modules and then assembling them together. But therein lies a problem because you would need to have a workflow that's a little bit more interactive in that potentially you'd need to have different classes being created by different agents. Now, there's a few ways to do this. One way is, of course, you'll want to use structured outputs as a way to get more clarity from the engineering lead about who's doing what. Use structured outputs as a way to construct the different modules that need to be written. But ultimately, you're probably going to want to call an engineer a certain dynamic number of times that will depend on how many modules the engineering lead wants to create. So it's not like you're fixed when you write the code that you know exactly how many tasks will be run. Now, Crew allows you to do that, and it makes it quite easy for you. You can create a task object at runtime while it's actually running. You can have a task object, and one of the fields you can have is have a callback, and actually the callback's with the agent, and the callback can make it create another task. So you can use this approach to build a more dynamic system where the results of completing one thing causes another thing to happen. And so you can assign tasks for each of the modules that need to be built. And that is the challenge for you. Add structured outputs and then add the dynamic creation of tasks so that an entire set of modules can be created and you can build a whole system. And then apply that. And I don't necessarily have a system to be built. You should apply that yourself to your day job. Think of a system that you would like, whether it's building a website, whether it's building an e-commerce platform, whether it's building something to organize medical records, whatever line of business, whatever profession you work in, think about the challenge that you could set your crew and have it be something which is dynamic and which could involve building an entire system with several modules. And once you've done that, of course, or while you're doing it, you must share your progress. This will be hugely something that will generate excitement on LinkedIn. So post updates there, tag me so that I can weigh in and get it more visibility. These are projects that really count, and it really helps you to build and solidify your expertise and demonstrate it to others. Actually, to correct myself there, I was right the first time. If you want to work with callbacks, then the way you do it is at the task level, not the agent level. And I'm looking right now in the Crew AI docs at docs.crewai.com/concepts/tasks, or just click on tasks right there. And it's worth looking through this because there's lots of interesting information here that you might want to try out. So the callback, you can specify when you create a task. In the code, you would say callback equals and then the name of a function that should be called back. And that is where you could potentially create a new task. So it talks generally about the fact that you can create tasks from YAML, as we know well, or you can also do it just by having the full code version of it too. As you can imagine, you can just pass in the description, the expected output, instead of specifying the YAML config. Then there's a lot of interesting stuff here that's worth taking a quick peek at. There's stuff we know about, but then there's also task guardrails, a analogous concept to what we looked at with OpenAI Agents SDK. Using guardrails, a way to validate and transform outputs before they're passed to the next task. It looks like it doesn't have the same constraint that OpenAI has, that it needs to be input of the very first one or output of the very last one. You can implement this at any task it appears. And then there's stuff about how to handle errors with those guardrails. And then structured outputs we know about. That is, of course, using the output Pydantic, or output JSON is another way of doing it. And now integrating tools with tasks is, of course, something that we know about. And creating a task with tools is listed out here, which is, that is what we're used to again. That is using a tool like the Serpa Dev tool that we already used, actually, right in there. Referring to other tasks. The output is automatically related to the next one, but you can define the context that should be used, and we did that. There's some stuff on asynchronous execution. I remember I said last time, I think, that we would be using async every single week, and we haven't actually used async this week. It's gonna make a comeback, don't worry. But if you miss it, then you can read up around asynchronous execution of your crew tasks here. This then is the callback mechanism. This is where you can implement a callback function. So if you had referred to it like so, then your function will get called subsequently when the task completes. And then there's more interesting stuff here. And more now on the guardrails. as well. And there we go. So I do encourage you to take a read through this, read a bit more about things like guardrails, which are interesting, and also about using callbacks. And some of this may be helpful when you look to build this more advanced flow when completing one task can trigger dynamically creating multiple other tasks. And very sadly, that brings our crew week to an end. It's the end of week 3. The end of crew week. We've done some great things. So we built some fun projects. The stock picker was really interesting. You haven't used that for investment decisions, I hope. And the engineering team was just mind blowing. Wow. So I really hope you enjoyed it. I hope you have the same feeling as me about Crew. I really love Crew. I prefer OpenAI's SDK, but I love Crew too. And I'm excited to now move to heavier weight framework in the form of LangGraph for week 4. It's going to be great, and I will see you then.